Hello and welcome to the second part of our first build from scratch series where we are making Pong. So just to recap where we're at. So last time we did our initial planning, which we've got here. We got our main level and our project set up and a bit of a skeleton of things. And so then this time around, what we're wanting to take a look at is, as a minimum, we're wanting to get some paddle movement happening. We want our ball to be moving. And then we want to be getting set up our scoring and our UI for that up and running. So I think the movement is a good point to start with here for this. So, okay, we've got our two different players here. Now, we are wanting to be using the new input system for this, so we specifically brought that in. So let's take a look at how we can go about getting this set up. So we know we can set up our player input, and so we'll have that on player one, and we'll have, let's look at setting this up on player two as well. So we've got each of these. So let's set up our input actions. So let's create a specific folder for this. And this is going to be our input configs. That looks good. So we're going to have the player one input actions. That seems like a thing that probably shouldn't be happening. Did that actually create the config? It did. That seems like a bit of an interesting bug. I'm sure it'll be fine. I hope so. So we don't need all of these different ones. We actually just need move. So I'm going to get rid of these. Now move. We've got left stick. Now WASD, we actually don't want to necessarily have all of those. Actually, no, we don't want the arrows. So we want to have left WASD for player one, and the arrows can go away. So I'm going to get rid of these. Those go. That seems like there's potentially some issues there with the input system. Now the thing with this is I want these, so WAS and D. I want, if we think about it, I think W and A can move up and S and D can move down. So it gives people a couple of options there. So it means I need to change it. So W is up, A is also going to be up, S is down, and I want D to also be down. And then we've got the left stick, which with that will only be using the vertical axis. So that looks pretty good. So we can save that. And then what I'm going to do is I'm going to actually, and this also had UI ones in there, which I'm going to get rid of that for now. Now this is a bit of a setup that I haven't done before with input ones where I've got multiple players. It's going to be interesting to see how this goes. So this, rather than being the left stick, I want it to be the right stick. So gamepad, and then right stick. For this, rather than being the primary 2D axis for the XR controller, I want to use okay, so that's, I think with this what I mean, actually we don't really need, I think VR support might be a little bit overboard with this. So I'm going to support gamepad and keyboard, I think I'll stick with. This, rather than being W, so I can just do listen for up, down, listen. So this is actually a really nice, easy way of being able to set these up. Then we listen for left. And then we listen for right. So that looks good. So we've got player 1 will have, player 2 will use the arrows in the right stick, player 1 uses left. Let's make sure we get rid of these extra ones that we weren't going to use here. That looks good. Not sure what's happening with those errors. Don't think it's because I've got multiple of these in the scene. Find out. So we've got player 2. That's good. Script-wise, we want to have then our so this is going to be a player. Actually, let's call these the paddle scripts. And we want to have then a C# script for paddle controller. Because both of these scripts are going to have that paddle controller on them. So this is going to be something that both of these are needing. So we'll bring that in here. So both have got the paddle controller. And if we look at the setup that we've got here, our behavior is currently send messages, which I think send messages will be fine. We could also go for invoking Unity events. Either approach is really going to work okay. But let's get these set up. So send messages, we know we should get an on-move message. So we should be able to be picking up an on-move. And then we want to Unity Engine input system because we want to see if we're working out what the parameters here need to be. But let's just initially see if we're getting any input coming through to these. So see if with the fact that we've got multiple player inputs, if we need to do anything different. We'll find out. So let's just run this. So we just want to get an initial sense of, am I saying stuff? So W, A, S, and D are working, so that's good. So player 1, we're getting input. Let's check player 2. Okay, so we've got input coming through, so that's good. Now we need to work out what we're getting passed in. Now I am going to be the first to admit that I do not remember the stuff that comes through. I just don't. Because with the input side of things, you're working with it, you get it up and running, and then you're not usually, I find, revisiting it a huge amount. So it can be really hard to work out what stuff you're actually getting coming through. So what I do is I'll chuck in a debug, and then I can see, okay, it's getting a send message, and what it's getting sent is this input value object. Which is, so it's this input value type. Okay, so it's just a way of using the debugger to actually find out what I'm getting coming through. So shrink that back. So this should be, we don't need the main menu. So input value move input. So debug log, and let's log out move input. And we can say get, so it should be a vector 2 that we're getting with this, vector 2. So let's log that out, just so we know that we're getting an input coming through and that we can check the particular value of it. Let's see. So we'll go for the right one first. So we can see that, yep, that comes through, so that looks good. So we've got our input there. So what I would generally do with this is vector 2, move, and call it something like input move. So we can say input move is equal to move input. Get, and we retrieve the vector 2. So that looks good, because this, we could see it does always return back to 0, so that's fine. We know that we'll definitely get it changing in the way that we need, which is good. So we want to move these paddles. So with the paddles, there's different ways that we could approach this. So one approach is that the paddles move in a very linear fashion, that they essentially have, well, actually, in a fashion where they have no inertia. So it doesn't take any time to, there's no acceleration, there's no deceleration, things like that. I think we'll go with that initially. I am going to set up a control for that. So movement mode, inertialess. And that's just going to be the only one we support initially. So serialize field, movement. That'll be the only one we support initially. I have a feeling that, because that could be an interesting enhancement, and this is the thing, as we go along, we think about what are some potential things we could do to enhance this. And I think that's a potentially interesting enhancement of having a sense of inertia there to the actual paddle. So if it's inertialess, then we would do this movement, could do the movement in update. I'm going to do it in fixed update because we are moving something that's got colliders and everything like of that. So just so we're going through the physics system, I think that'll be important. So if the movement is equal to movement mode inertialess, then we'll do the updating. So if we're going through this, I want to be controlling a rigid body because I want to be making sure that I'm moving and having collisions. I've got good control over that. And because I potentially want to longer term go towards having things like inertia-based movement where I've got acceleration, deceleration. If I have a rigid body, that's going to be much easier to work with. So that's good. I'm going to retrieve that rigid body here, which, again, making sure that I'm following sort of good practices here. This has to have a rigid body. So require component type of rigid body, just to ensure that I can't set a paddle up on something that doesn't have a rigid body. It also needs to have that player input. So I think require component type of player input. So you can have multiple require components like this. It's just a good way of enforcing that this is a thing that has to actually be there, which I think is really important. So, okay, that's good. Well, I know for movement, I know I'm going to need, actually I don't need that as a serialized field anymore. I'm going to need a speed. So I think initially we'll try 1 meter a second. So we'll go for the speed there of that, and we can say the max movement. So that's the maximum distance the paddle is allowed to move from its center point, which we can check this by. So we can kind of go up to, and I reckon we make it that there's a little bit of a gap there. So I reckon we go for 3.5 either way. So it's not going to collide into it, but we have that. So, okay, that looks pretty good. So we've got the speed, we've got our max movement. I think we want to keep track of our center point. So vector 3, so origin point. So origin point will be our transform position. And so that's good. We've got our origin point. And I think, no, I don't think we need to, I was thinking we could potentially have something where we're controlling what the way is that it's able to move, but we know it's going to be along our Z, which is our forward. So that looks pretty good. We've got our 2 paddles. Now, we don't have a rigid body on these yet, so let's make sure we've got our rigid body. Now we want to turn off gravity, so we don't want these having gravity effect, and actually we want these to be kinematic, because we don't want, so kinematic is going to mean that these can affect other things, but other things can't affect it. Constraint-wise, now kinematic should be enough that we don't need to these, but because I am eternally suspicious and distrustful of code doing exactly what I want it to do, I'm going to make sure that it's constrained, so physics is only able to move it in Z, because we've already established that that's an okay way for it to move. So, okay, we've got our speed, we've got our rigid body, things like that hooked up. So, our input. So based upon our input, that is going to determine how much we are moving towards a particular direction. I would say input move dot y multiplied by our speed and time dot delta time. And then that is going to adjust our current value. So our new Z position, it's going to be our current Z plus how much we should be moving. And then we need to clamp that. So our clamped Z position, so new Z position is our clamp. And we are clamping new Z between negative of our max movement and max movement. So we're just keeping it so it has to be within that particular range. Because then what we're able to say is that our transform dot position is equal to our origin point plus a new vector 3 that is going to be 0, 0, and new Z position. Actually, we could also, no, that works. I was thinking we could use a transform forward, but I think this is fine. Let's see what that does. So we can set that up. That should give us some movement there, but is it going to give us movement in a way that we are happy with is an important thing. So straight away that speed is way too low. So that's something where we can immediately see, yeah, that speed is way off. So I'm going to start with doubling it. When you're adjusting values, don't initially do small changes, do very large changes. That still feels really slow. So even though I'm editing, I can still, I'm going to jump that all the way up to 5. Better, still not feeling fast enough. Let's try 10. No, so that's still, it's taking quite a while to move. Going to double again, not 210, let's just try 20. That feels a little too fast, but maybe if that had a bit of a ramp up in speed, that could be okay, because that feels really rapid. That feels like I'd be able to respond in time, but I actually feel like I want to have a little bit of a build-up of the speed there. I think would actually be really good. So that's actually going to mean we have a little bit of inertia in there. Inertialess. So movement mode is then inertia. So we can have. So what I'm thinking of how I do this is the input can slew towards the particular one. Now I could do this in the input system. Absolutely could do this in the input system, but because it's something that's very tightly linked to the behavior of these paddles, I actually think it's going to be better to do it inside the controller here. So what I would be setting up, I think, then with this is the so I want this to be the larger the amount is, the more rapidly it adapts. So I think speed, slew, rate. So slew as in it's how quickly it moves towards that particular value. So I think I want that to be, I'm going to start with that as being 1. So it would take 1 second for it to go from 0 to 1. So there's a ramp up time there. So that's the input move. I think vector to input move with inertia, I think. That's what I want there. So this would actually then be slewing towards that value, I think. Yeah. So what I would do is this would actually be worked on by the update here. Now I will eventually move these up into this section. This is just for temporary, for working with this. So I think what this would do is the input move with inertia. Actually, I can probably switch these over to just being floats because I'm only using one component of it, so I might as well just extract that out so I'm not having to be keeping around extra data that I don't need. Because then I think this can do a mathf move towards, so our input, so our current value is the input move with inertia. We are moving towards that. And then max delta is going to be the speed slew rate multiplied by time dot delta time. Because then down here, if our movement is with inertia, then all this changes is which one we refer to. Okay, clamped position, update the position. So this is really down to the feel of this, and I want this to have a really good feel for how it plays. So input move with inertia. Now, so it's going to always move this towards that. Now, one thing I am not sure of is how does this handle with it going to negative values when I'm giving it a positive value here? We shall find out. So what I'm going to do is I'm actually going to make it that paddle 2 uses the inertia-based one, just so I've got a point of comparison. So I can move paddle 1, and that's no inertia. So that works. Now, one thing I notice is it is very floaty. Plus side, the negative thing seems to work. So it feels, actually it does, it's feeling a lot better. I'm really liking how that is currently feeling. Let's try a faster slew rate. Do notice if it's stopped, it does potentially, like to turn it around. That's one of the things, and that's something where what I could do is, okay, checking for sign changes. So I think is there a mathf sign of input move? So if the sign of that is not equal to sign of input move with inertia, so if there's been a sign change, then I want to move with inertia is 0. So if there's been a sign change that's reversed my input, then I want to just zero out the current value. So it's going to snap it. It's going to make it be able to be a bit more responsive, which I think is going to make it feel a lot better. Because it's those moments where needing to do sort of rapid changes that it feels off. That actually feels really good. It's responsive, but it also has a bit more of a weighty feel to it. I like that. That feels good. So I'm going to switch both of those to inertia. And we've got player movement done. So our done list is increasing in size, which is great. And I'm going to reorder these because I want them to actually be in order because it was annoying me. There we go. So that's cool. We've got our movement happening, and I'm pretty happy with how that's behaving. Now we want the ball moving. So one of the things I know is if it's going to be hitting stuff, probably want to start getting some tags set up. So let's create some tags here for wall. We want player 1 goal and player 2 goal. I want these all set up, and I don't know if I need a specific tag for the ball, but you know what, let's set it up. So our left wall is player 1 goal, bottom wall, that is just wall. Right wall is player 2 goal. I'm actually going to rename these as well. Player 1 goal, player 2 goal, just to avoid confusion. I've got the top wall. We have the ball. And then I also want to add in tags for the paddles. So player 1 paddle and player 2 paddle. That looks good. Should be able to tag those. Player 1 paddle and player 2 paddle. Good. So just have everything tagged. This will just mean that when we're colliding with stuff, we're able to be providing sort of feedback and everything there. So the ball, we want that to be physicsing around, so it's going to have a rigid body. We will turn off gravity, and we don't want any rotation happening. And position-wise, we only want it moving in X and Z. We don't want it to be able to move in Y. So we just constrain all of those. Now, collision detection, this is potentially going to be moving fairly quickly. So I think for accuracy, we probably want to switch it over to continuous collision detection. Is I think going to be a little bit more reliable. We're going to then create a folder for the ball script. So create a ball controller, and then I can just add that in. Now, what I will eventually do is this ball will be something that gets spawned into the world. For now, I'm just going to have it exist here. I just want to take a look at relative heights of things. That looks pretty good. All right. So, well, the first thing this is going to need to do, it's going to need to launch. Launch. And we might want to have it that we can control that direction. So maybe we want to have a launch direction like random towards player 1, towards player 2. So that looks good. Serialized field. Launch direction. So for now, we're just going to make it random. Then we'll just pick. That looks good. And I might make it that this, you can override it. No, I won't have it that you can override it. Might end up, I feel like we might need that at a later point, but for now, I won't. We want to have initial speed. So we already know from moving the paddles, those needed to be pretty quick. So I have a feeling, probably want this to be I think 30 maybe. We also want to be able to have minimum speed, which I think the minimum speed, we don't want to be able to slow it down too much. And then I think we want a maximum speed. So we want to be able to keep a level of control over this. Ball is going to need we know it has the rigid body. So that's good. We'll have that retrieved so we can do things with that. So grab the rigid body. That looks good. So then for launching, okay, first thing is to pick the launch direction. So if the launch direction, if that's random, so I'm going to pick, okay, vector 3, launch vector. So initially, I'm going to set this to 0, just so we can clearly tell if it has failed to work. So if it's random, then launch vector can say random range. So if we do a dice roll, doesn't really actually matter. We could do a random roll from 0. Key thing we need to remember is that it needs to be, if we're using integers, it's exclusive of the max. So if I did 0, 2, I can only get back 0 or 1. Whereas with floating point ones, it's inclusive. Now in this case, because it's a coin flip, I think using integer and 0 to 2 is a good way. So if that's equal to 0, then our launch vector is vector 3. So it's moving in x, so I think we'll make that left. Otherwise, vector 3 dot right, because of how I've built things in the world, this is going to be valid. So that looks good. Otherwise, if the launch direction is equal to towards player 1, then the launch vector is vector 3 dot left. Otherwise, launch vector is vector 3 dot right. So here, pick the launch vector. And then let's launch this. Launch the ball. So we can say ball, rigid body, its velocity. I'm going to say that is launch vector times by initial speed. Now, this isn't putting any angle on it. So what if we wanted to angle this a little bit? So we'll look at that. But first, let's just have this launch. Let's just make sure it starts moving and get a sense of whether those speeds feel about right. So we can let this run. Should see it, in theory, should be applying a velocity to it. Now it's not. So that is because nothing's calling launch. So I'll actually have I'm going to make it just a ball for now. Auto launch. And then what I will do is in fixed update, because we're working with physics stuff here, so I want to be doing it in that. So if auto launch is true, first thing I do is set it to false, then launch. So I'll just let it perform an auto launch. So let's just see how this goes. It should pick a random direction and start heading off in that. Now that was way too fast. So maybe let's lower this down. So if I'm lowering the initial speed, that's going to mean I want to change these other ones as well. And we can see even with that being continuous, that was way too fast. Okay, that felt all right. Still pretty quick. So I might lower that to 5 and a maximum of 15 and maybe 1. Let's try that. I think 7.5 and maybe 5. I want it to be controllable and manageable. That's all right. That seems okay. So that's pretty good. We've got it launching. We want it to be doing, actually a bit more than that. So we could set up physics materials. So let's see what happens if we do this. We create a physics material for PhysMat paddle. Let's also set up one for the ball and another one for the walls. Just so everything has got its proper materials that we can then adjust the behavior of. So the paddles, we've got that. Ball gets its own one. Just lets us customize each one individually if we need, and then the two walls get their ones. Because if we look at these materials, they have this bounciness that we can set. So let's make it that everything, the paddle, the ball, that there's a little bit of bounciness there in all of them, and see what that does. That might give us a bunch just for free. So we can see that moves, so that's good. And we can see it is sort of slowing down a little bit. That's because the bounciness is not going to add to the velocity there. So the bounce combined, and we can change this mode for all of them. So we could say the bounce combined, that is the maximum. Let's see how we go behavior-wise with this then, in terms of whether this gives us at maintaining speed. So we can see it does still slow down. So bounciness, let's say that's 1. And then let's actually start this again. So those are 1, and we'll go for maximum and let it run. And let's see how it goes for maintaining speed there. So we can see that's holding speed. So a bounciness of 1 is pretty good there. Let's just see what happens if I have this moving. So at the moment, we don't get any angling being applied. If I was really precise, there we go, and I hit on the edge there. So that's good. So we've got some decent behaviors happening already. So if we look, we've got the basic ball movement, but we want to have this doing a little bit more. So one of the things is we want to keep the speed constrained. So let's get our ball, rigid body, and that velocity. And then let's get that vector and pull that out. Velocity is that. So then what I want to do is to clamp this, to keep it between that min and max speed. I want to set the velocity, well, that's equal to my velocity that I then normalize, which is going to bring it to 0 to 1, multiplied by, and then I can say a mathf clamp velocity dot magnitude minimum speed maximum speed. So it's going to keep it between that. Now I don't want this to be running, I don't need this to be running all of the time. So what I could be checking is if the ball, the velocity is less than minimum speed, or ball, the velocity is greater than the maximum speed, then, and actually I need their magnitudes. So magnitude, then I do the clamping. And I probably don't actually need to pull this out like that. I can just work with it directly, is fine. Oops. because that will then give me lamp and wall velocity F needed. So it just means we're ensuring it's staying between values we control. For auto launch. So we're checking for that. So that's good. Now the other thing is if we're not doing an auto launch, if it's just stationary, we don't want it to start moving. This would cause it to start moving. So we can check. I believe. Can we ask it if it's yes? We can ask if it's sleeping. So if the rigid body is sleeping, we're sleeping. Do nothing. So rigid body will be sleeping if there's nothing happening to it, because what we want to check is if we don't do an auto launch, the ball shouldn't start moving, and that's the thing with having that minimum maximum speed is cool, but we only want to have that happening if it's actually awake and has been launched. So let's run this. We can run this again. So there we go. So we've got clamping of the speed happening, and we've got auto launch being able to happen, which is good. So we've got a few other things that we need to sort of then be detecting. So we've got on collision enter, collision other. So what we do is going to depend upon what we've hit. So if other, and we can't just directly do the compare tag, we want to do game object compare tag. So if what we have hit, and we can see our set of tags here. So if we have hit player one paddle, so we want to keep track of which paddle we've hit. So if we've hit player one paddle, maybe we've hit player two paddle. Or maybe we've hit the wall. Tag the wall. So that's good. So we can see which one we've been hit by. So I want to, and this is just because I have an idea of something I might want to do later on. I'm going to have an enum last touched by no one, player one, player two. Because there's a couple of enhancements that I'm thinking of that could be really useful to know. Last touch by. No one. Because we can then down here and say, well, last touch by is equal to player one. Just as a handy thing to know. We'd also be able to be kicking off sounds here. So this is a useful thing, and I might put that hook in now. So on hit paddle. I'm not going to actually put the logic in for it. But just as I'm setting these up, I know that it's the thing that I'm going to need. So we might as well put that in on hit paddle. We know there's the wall as well. So on hit wall. And I learn how to spell it. So we can have on hit wall. So that's good. Now, if I've hit a paddle, I want to also have sort of different behavior in terms of what it actually does for movement. Because this at the moment, I'm leaving the behavior in terms of it, what it does with its speed, things like that. I'm letting that be controlled by these physics materials. I actually don't want to do that. I want to take full control over it, and I want to have it that these physics materials, I'm actually going to get rid of them. I don't actually want them. because I want to do this all manually. So I set them up as an easy way of testing intentionally, but I want to actually not be using them. So we're going to get rid of these physics materials here because I'm going to do this manually. I want to actually control how that movement goes manually. So when we hit a wall, so a wall is going to be a fairly straightforward one. And what I'm going to do is I'm actually going to pass the collision info in because I want the decision in terms of what happens to be handled with these and within the context of stuff. So when we hit a paddle, okay, straightforward thing is as soon as it hits something, so we know if it bounces in, it needs to then bounce off, not the exact opposite of the way that it was going. So it's not the exact opposite of the way that it was going, but it's the reflection of it. So if we picture it's coming in on an angle, then it needs to go off on that, the complementary angle there. And we actually are able to do that. So we know we've hit a paddle. So what we can do as a starting point is at that point where we hit the paddle, with our collision, we can get our contacts, and we're only interested in the first sort of contact. So we're only interested in that first one, which can actually just retrieve this. Let's go for get contact 0, and then I can get the normal. The reason I want that is because there is this thing called vector 3 reflect. So I can say this is the direction that is coming in, which that is going to be the ball rigid body's velocity. And then the normal we've got here. So I want to be able to actually then say the ball rigid body velocity, it's this. So reflect the velocity. I'm going to do the same for the wall. The walls will follow largely the same process. Let's try this. What we want to see is ideally that it still bounces back and forth exactly as it did before when we had the bouncing materials. But now it's happening something where we're carefully controlling it. So it doesn't bounce back. So let's take a look and see what are we getting for our velocities at this point. So it could be that at this stage the velocity is already gone, or it could be that the normal means that it's because it's an exact reciprocal of it, it might be causing issues. So velocity we can see has actually gone to 0. So with that, if we have a look in our collision info here though, then our contacts probably has a velocity here. So we can see relative velocity. So that we can actually probably use. So we could use that other relative velocity. So it's a handy thing when we've got collisions, we do get info in terms of what was the speed this collision happened at. So although our rigid body's velocity is updated and has gone to 0, we can still access and see how fast did we hit. So let's try with this then. So we'll run it. So still get the same behavior, but let's check and see whether is this a case that so what I'll do is debug log, just because there's a few different bits and pieces I want to see here. So I want to see the relative velocity, and I want to see the normal. And then finally, I want to see what it is calculated here. Just to make sure that it's calculating a value that looks correct. So, because what we want to see is that third one is the opposite. So with that, we did not save, so we did not get our output. And we need to make sure we've got semicolon. So let's check and see. Because if we can use the reflect is going to be a far more reliable way of this working, and it gives us a lot of control over it. So in C, we got minus 7.5 was the relative speed. And the normal is minus 1. So the normal is pointing that way. The velocity was pointing that way as well. So we might, with this, need to have a look and see if we got, so it's a relative linear velocity. So we might need to actually use minus here with this. I am considering potentially keeping track of the last velocity we were moving at here. And I actually think that might give us a better behavior. Current velocity. I think this is actually going to give us a better tracking here than just actually, because I feel like the relative velocity, there's potential there for that causing issues, there being some weird edge cases with it. So I want to set this up so we're keeping track of the velocity. I think is going to be a more reliable method. Just because that relative one is based upon both of them, and that means if the paddle is moving, there'll be a different value there, and I want to have a little bit more control over it. I want it to be based off of how fast we're moving. So we can see that's working nicely. We're getting the reflecting, so that's good. So that's part of what we wanted the behavior-wise. Now, the other thing we want is when it launches, we want it to launch on a bit of an angle because we want to know that this reflection is working when we come in from an angle too. So pick a launch angle. So we want to be able to rotate this vector a certain amount. Now, for doing that, if we take a look, we can, for rotating a vector, we can do that via multiplying it via a quaternion. So if we did launch vector times by, I believe the quaternion has to go on the left. So we can create a quaternion from a Euler angle. Well, we want no rotation about x. There will be a rotation about y. And there will be no rotation about z. So let's pick a float, and let's say this is the max launch angle. We might want that to be, maybe we just keep that as 30 degrees. So this will just put a little bit of a rotation on it. So we can rotate a random amount between minus of that and that. And okay, so it needs to go the other way around, I think. There we go. That should give us a little bit of rotation on that angle. Let's see how that looks. What we're looking for is it being able to launch a little bit of on that angle, which it does, which is good. Let's try that with me actually hopefully managing to intercept it, which I did. So that's behaving pretty nicely, actually. I'm liking how that's moving. Now, one of the things I want to be able to do is I kind of want to be able to skew it a little bit based upon the velocity of the paddle. So being able to use that to adjust it. And it seems like it's already doing that a little bit in that that is sort of changing the... My reflexes are not great, and this is very much going to... illustrate that. Third time lucky? Maybe. Oh, god damn it. I was never amazing at Pong, as you can tell. You are kidding me. Okay. I swear, this time definitely going to get it. Otherwise, I'm dropping the speed down to something. Ah! And I did manage to hit it, and then it went off screen. Of course it did. There we go. So it does. There is already, I think, a little bit of that. And I'm going to drop this launch speed so that I've got more of a chance. Because I think it is already skewing a little bit when the paddle hits it. That is just embarrassing. But I'm not going to edit this out. So enjoy a lighter moment of some laughter at my expense. So yeah, I'm not managing to really do the sort of steering of it that I want to be able to do. So I want it to be the case that these, when I'm hitting it, that there is a component of factoring in the way that the paddle's moving. So what I'll be able to do is other game object get component. Because those paddles are being moved, I can get their rigid body and I can get their velocity. So I think what I can do here is I'm not so concerned about the speed. Actually, no, I think the speed would be useful to have factored in there. So I want to be able to blend this velocity with my current, with that reflected velocity. That's what I think I want to be able to do. So vector 3 reflected velocity, and then vector 3 paddle velocity. So that's going to be other game object, get component, rigid body, velocity. So this is going to blend with the paddle velocity. And what this will do is the ball rigid body, its velocity. So I want to combine these. So I want to say it's the reflected velocity plus, and I think paddle velocity times paddle velocity weight. So I want to be able to have it that I can customize how much of the paddle's velocity comes through. Serialize field, paddle velocity weight, and let's say at the moment just all of it comes through. The entire weight of that comes through. Now that means then with this, the moment those paddles, there isn't really a velocity being applied to them. So for that, I need to actually inertialess. It's an instantaneous thing. As soon as movement stops, it stops. But I think it would be still good to have this be a velocity that it's setting. So I think we do paddle RB velocity, and that can be equal to, that's going to take in the input movement and the move speed. So there's not going to be any delta with that. So because we're launching it at a particular speed, we don't have the delta in there. So I think that's going to be the input movement, and the direction is going to be our transform forward. So I think that will work. Now I'm going to need to put in stuff for clamping this position, which is fine. I'll be able to do that. So that's updating the velocity. So this one is going to be largely the same, except it's using input move with inertia. So I'm just needing to convert this over to velocity. I should have really set this up using velocity to begin with. So what I now need to do is if we've gone out of range, is I need to be clamping and keeping us within our actual range. So I still want to be moving with velocity because I want to be able to actually just grab that info out and be able to retrieve that. Or the other option is I could get a simulated velocity from it. That's actually the other approach. I'm going to do that. I'm going to try that first, a simulated velocity. Because, yeah, I think I could potentially do that. Because I know the paddles have this script on them. So what I could get here is, rather than going to the rigid body, is I could get the paddle controller and I could get simulated velocity. I think this might work better in terms of giving me control over this. Find out. I might need to change that around, but we'll see. So I've got simulated velocity. We do have then, depending upon which movement mode we're using. So if the movement mode is our inertia one, and I think this will be, so we've got our input, and that's fine. So we could say, okay, the simulated velocity is going to be our transform forward multiplied by our speed multiplied by the input for the move. Otherwise, for inertialess, I'm not going to do an else for this because it's kind of meaningless because we're returning. So input move with inertia. And then we're going to otherwise return a vector 3, 0. So that looks okay. Thing will be when we are at the edges. So when our Z position is at our very edges, we need this to go to 0. So this otherwise is looking viable, but we need to pick up that of, okay, if our transform position Y is greater than or equal to max movement, actually, math F absolute value, just so we know if we're at that max movement point, then we return 0 as well. Vector 3, 0. At the edge, no movement. So just think this might work okay as a way of simulating it. Because what this should allow us to do is that if we're moving the paddle in the same direction as the ball, then we can increase the speed. And if we're moving it in the opposite direction, then we can decrease the speed, which I think might work okay. So we can see that really ramped it up. So I think that we lower the weight. I'm also going to set the launch direction always towards player 2 with a lower speed. So same direction. Oops. I'm going to lower this launch angle just for testing. So same speed, so same direction should mean we get a speed up. And I am just the worst at this. For that, no change, which is what we expect. That moving in the same direction, it built up the speed quite a bit. Let's try moving in the opposite direction. So we'll just get it running and then we'll move it in the opposite way. So that was moving it the same way. You can see that really does increase the speed quite a lot, which is good. That 0.5 feels actually about right, I think, for the velocity. Then we will want to be able to change the speed. I feel like I should have just set up the AI player to begin with. So we're moving, and that moves it faster. Let's just try that again. It doesn't always tend to increase the speed, which I guess to an extent makes sense if it's moving a particular way. Let's just check. I think I'm actually okay with that always tending to increase it rather than decrease it. We could tweak that more. So we could make it that, if it is moving opposite, that it has a bit of a restraining effect on it. But I actually kind of like how that's moving. I feel like that's pretty good. So final bit that I want to add in is just then checking void on trigger enter, collider other, if other dot compare tag, player one goal, otherwise if other compare tag, player two goal. And let's just log out so we know which ones we've hit. One. Just make sure these are working, so we've got all the bits, because then we can start next time around setting up scoring. So this should be easy because I'm going to be pretty reliable at missing. So yep, player two. Let's just check player one. That's working as well. Of course, I would manage to actually hit it when I need to miss the ball. My coordination. There we go. And we got player one goal. So that's good. We've got the behaviors behaving the way we want, which is great. So ball movement is sorted. So I think that's a good point to finish this one. We've got those up and running. Next time round, our goal is going to be the scoring and score UI and the game over side of things. So I think that will be good for the next set of stuff. And then we'll see how we go with the other bits and pieces. But the key bits we got up and running. We've got our movement using the input system. We experimented with a couple of different input modes. So our inertialess mode, which we felt just didn't feel quite right. It didn't have good feel for the movement. Inertia-based one had a really good feel though. We did need to set up this extra property just so we can easily get back a thing indicating our velocity, just because we're doing the movement here with the transform position. So I'm actually going to change that to use the rigid body to move the position, just so we're going properly via the physics system for that. I think it's going to be better. So paddle RB, move position, just a little bit of cleanup. And then we set up for the ball. So we did initially use physics materials, but because we want precise control over it, we want to be able to do things like blending in that little bit of the velocity from the ball. We switched away from physics materials to actually managing it in the collisions itself. So that's at a pretty good point. So we'll be coming in and then adding in a few extra bits in the next time around. Thanks, folks. If you're looking for the code for the project, then in the description below, you'll find a link to the GitHub. And on the GitHub, I've got the code for this project and for all of the other projects. They're freely available. And if you have found the video helpful and you'd like to support the channel, then throwing in a like or subscribing is always a huge help. If you're looking for further ways to support, then I do have a Patreon set up, and that's going to help me keep managing to do these videos for a long time to come, which is going to help more people make cool things. And that's awesome, because that's what this is all about, is helping more people make more cool things. And that is all. Thank you.